In this video, I'm going to solve one practice question on forecasting time series with both seasonality and trend pattern. Question number 23 from chapter 8. So I have the question here. We are given the quarterly sale information in the past 3 years, and we want to make forecasts for the next year using seasonal and trend forecasts, right? So this question has multiple parts. I'm going to go over them one by one. So in part A, construct a time series plot. What type of pattern exists in the data? So for this one, we want to make a simple line chart, but it's very important to have the numbers in a column. So this question has no data file attached to it, so it's up to you to type the numbers. So if you want to have all the data, in order to be able to see the trend, especially the trend, you need to have all the numbers recorded in one column. That way you can see the trend. You can have the whole time series in one line. So this is how I typed my data file. So I have the sales for year 1, year 2, and year 3. And I also indicated the quarter number, all right? So now this is my data file. So I'm going to go ahead and answer part A. So I just need to insert a line chart line with marker. And I'm just going to clean it up a little bit. Add the axis title, getting rid of the grid lines, and also add the trend line. So the axis title, I'm taking it as sales. The question didn't determine what the variable of interest is, but I'm taking it as sales or demand. You can also consider it. So period would be my period, or quarter will be my the axis title for the horizontal axis. So obviously there is a trend effect. So when you add the trend line, you see that there is a gradual, consistent increase in the sales from year 1 to year 2 and to the last year, year 3. So we definitely have an increasing trend. Let's check to see if we have seasonality as well in the data file. For that, we need to take a cycle, compare it to the next cycle, compare it to the next cycle, and see if we see any similarities in the movement of sales in one cycle compared to another cycle compared to the other cycle. So as we can see, this sales goes down in quarter 2 and then comes back up and up. And the maximum happens at the last quarter in first year. So down, up, up, down, up, up. So maximum, minimum, down, not up, but doesn't decrease significantly. So it's a slight, almost the same, slightly decreased, but not much. And then jumped up to the maximum level. So this one actually can be as a result of an external factor, something other than the seasonal effect. All right, but 2 out of 3, this effect is actually taking place. Maximum always happens at the last period. Minimum should be in the second. So this is okay. This is true. And this one, even though it's not, but it's not a big deal. So in general, I can confirm that seasonality exists in this data series as well. So I can say both seasonality and trend exist. So what type of pattern do you observe? We observed a trend, we observed seasonality. Next part of the question, use a multiple regression model with dummy variables as follows to develop an equation to account for seasonal effects in the data. So we want to ignore the trend and just focus on the seasonal effects by having 3 dummy variables, quarter 1, quarter 2, and quarter 3, and come up with the regression model, and then compute the quarterly forecast for the next year based on the model you developed in part B. So I'm going to answer part B and C and together actually. So if I go back to my data file, to the data sheet, I don't need this. So my objective would be to make a forecast for the next year. So this is what I'm going to be looking for next year. All right. So, and I'm going to take part A from here, put it at the end because I need to have space for forecast and for the independent variable. So the question asks us to create 3 dummy variables, quarter 1, quarter 2, and quarter 3. And quarter 1 is defined as this. I want to have, if the quarter number is 1 for all these 3 numbers, 4, 6, and 7, the dummy variable quarter 1 should take 1, otherwise 0. So going back here, if quarter number is 1, put 1. If B3, you don't have to put the sheet names as long as it's in the same sheet. So if B3 is 1, put 1, otherwise put 0. If quarter number is equal to 2, put 1, otherwise put 0. If quarter number is equal to 3, put 1, otherwise put 0. And this is the formula that I'm using here. And then once you set it up right, you can drag it down. And that way, just check it for the last, it's always a good idea to check it at least for 1 year. So for the last year, 1, 1, 1, and then for 4th quarter, we have all zeros. So that's perfect. And so the dummy variables are ready. And now I want to develop my seasonal model. So for part B, I'm going to go ahead and run the regression model using the dummy variables. So regression, the Y range would be sales. X range will be quarter 1, quarter 2, quarter 3, all the way to the end of the 3rd year. So make sure to have the same number of rows here for both Y range and X range, right? So 2 to 14, 2 to 14. And then check labels, if you have labels, and put it at the end after part B. Again, we're just looking for the equation here. We're just looking for the coefficient. So, okay, this is what I'm looking for. So, I mean, if you want to write down the equation, sales is equal to y-intercept plus the coefficient for quarter 1 times quarter 1 plus the coefficient for quarter 2 minus 3 times quarter 2 minus 2 times quarter 3. So that's the equation that I need. I'm gonna copy these numbers, Control C, and I'm gonna bring them up here and paste them here. I can transpose and use the sum product. That's what I'm gonna do. I'm gonna transpose. I copied, Control C, and now I right clicked here and then transpose. So now I have, I'm just gonna write down. So this is my seasonal model. All right, so for seasonal forecast, will be y-intercept F4 plus sum product of the coefficients F4, comma, the values of quarter 1, quarter 2, quarter 3. All right. Enter. And just make sure to have the dollar signs for the quarters, for the coefficient, B0, B1, B2, B3. Make sure to have that. And just drag it down. So that gives us the seasonal forecast, and this is the formula that I'm using. If you don't like some product function, you can just multiply the coefficient for quarter 1 times the actual value of quarter 1 plus the coefficient for quarter 2 times the value of quarter 2 and coefficient for quarter 3 times the value of quarter 3. So that's going to give us the seasonal forecast. And these are the values for it. This actually is the answer to part C of the question. So I'm just going to write it down and put it here. Just the numbers, put just the numbers here, and that would be the answer to part C of the question. You don't even have to do this. I mean, if it's in the exam, as long as I see those, that's fine. You don't have to really bring them down here. So seasonal forecast, the next part of the question. Now, part D, use a multiple regression model to develop an equation to account for trend and seasonal effects in the data. Now, we want to have both trend and seasonality. Use the dummy variables you developed in part B. So we're not going to change them. We're going to use them, all 3 of them, to capture seasonal effects, and also create a variable T such that T actually takes 1 for quarter 1 in year 1, 2 for quarter 2, and 12 for quarter 4 in year 3. So it's basically period numbers, 1, 2, 3, 4, all the way to 12. So create these values and develop a multiple regression model, and in part E, compute quarterly forecast for the next year based on the model you developed in part D. So going back here, so we have the dummy variables. We also need period. We also need the T, actually T variable. So for that, I'm going to need to add them right after my dummy variables. Remember, if you want to add those, if you want to have your independent variables in the regression tool, you need to have them connected to each other. They have to be next to each other. So you can't have your period here, for example, or here, for example. It has to be connected to these 3. So because of that, I'm going to insert, right click on G here, and insert one column, and I'm going to call it period or as the question asks, T, period T, and it's going to be simply 1, 1 plus 1, and just move it down. So it goes from 1 to 12, but if you want to make a forecast for the next year, for year 4, you should plug in 13, 14, 15, and 16 for the quarters of year 4. All right. So this would take actually this would actually take care of the period number. So now we need to develop the seasonal and trend model. For that, again, we need to go to data analysis, tool pack, regression, Y range. That's not gonna change. This is what we want to predict. X range now is gonna change. We need to add the period factor as well. So quarter 1, quarter 2, quarter 3, and period all the way to the end of year 3. Again, it ends with 14, ends with 14, 2 to 14, 2 to 14. Check the labels and put it right after wherever you want to put your part D. So I'll put it here, A65, and okay. So this is now the answer to part D of the question. Again, I'm just gonna write down, we wrote it. I'm just gonna write down sales is equal to 3.42 plus 0.219 quarter 1 minus 2.188 quarter 2 minus 1.59 quarter 3 plus 0.406 for period. So that's the equation that I'm looking for, right? But at the end of the day, when I want to make forecasts, I need just the coefficients, B0, B1, B2, B3, B4. So I copy them, I select these values, these cells, Control C, and I just bring them up next to my values here, and I right click and transpose. Again, I'm going to use the sum product function. I have the seasonal forecast. I'm going to go ahead and this time have seasonal plus trend forecast. So my forecast is going to be wait, let me just put the title here. So it's going to be seasonal plus trend model. So now this is my model in part D that accounts for both seasonality and trend effects. So the forecast is going to be coef B0, F4 or Command T, add the dollar signs, plus sum product of coefficients of quarter 1, quarter 2, and quarter 3, and period, F4 fixed times the value of quarter 1, quarter 2, quarter 3, and period. All right. And just to show you the formula here, this is the formula. And we just simply need to drag it down. That way, it'll take care of the formula by itself. So now I have forecast for the next year. So these are now my forecast for the next year. So part D, and then in part E of the question, what is your forecast for the next year using these values? So I just put them here, just the numbers, and that would be part E. Right? You can say quarter one, quarter two, quarter three, quarter four, but that's okay as long as we can see them here, right? The last part of this question is the model you developed in part B or the model you developed in part D more effective? Justify your answer. So what's happening here is that we now have two forecasting methods, a seasonal forecast, seasonal and trend forecast. So we have two sets of forecasts for the next year coming from different techniques, all right, with different assumptions. So now we need to compare these two. How do we make comparison? By finding the forecast error, by finding one of those measures that we use for forecast accuracy, MAE, MSE, or MAPE, and then take the forecast that provides us with the less error. So I just need to find, in order to be able to quantify, in order to be able to justify, we need to find the, either error squared or absolute value of error or absolute percentage of error. It's up to you. The question has not specified. I'm going to go with MSE, but it's up to you, whichever you feel more comfortable. So I'm going to add maybe 2 columns here, insert 2 columns here, and I'm going to call this error squared. This error squared is for seasonal. This one is for seasonal and trend. Okay, so error squared, parenthesis, the value of the sales minus the value of the forecasted value, squared. And we just need to drag it down all the way to year 3, to period 12, right? Because here for the 4th year, we don't have the actual values, and it's not gonna show up right. So you just, you are able to find it for all the periods for which you have seasonal, for which you have a forecasted value, as well as the actual value. And we just need to do exactly the same thing, parenthesis, value of the sales for period 1 minus value of the forecasted value squared. And just drag it down. All right, so now we have error squared in both sides. So MSE of seasonal would be average of these values average of these numbers. And the same thing, if I just repeat the same thing, but this time for seasonal and trend. So as you can see here, the MSE is the average of error squared. Now this time is much lower for seasonal and trend forecast. So it's significantly lower. So because of that, we would take this as our as a better model, seasonal and trend, and we just remove. We actually take these numbers as our forecast, and I'm just gonna change the font color, like make it gray, so that way we know that these are better. And for part A, B, C, D, E, F, part F, model in part D is more accurate since its MSE is significantly lower. So that's the best way to answer that. And like I said, the question has not asked for MSE. You can do MAE or MAPE, but just to also to visualize the difference, I'm gonna go ahead and add another. I mean, we can do it on this one, on the already created line chart, but I'm gonna create another one. So getting rid of the grid lines. I don't worry about the axis. Let's just do it. So, okay. So I have the graph here. I have the graph for the actual sales. I'm gonna add the seasonal and trend forecast to my line chart and see how they actually are following the actual or close to actual values. And that way we can comment on the accuracy as well. So if you right click on this on this graph and then add series, so seasonal forecast, and then the values are the seasonal forecast values. Okay, so you see it just adds it here. Add again seasonal plus trend and the numbers. Okay, all right, and okay. So this is great. Maybe just add a legend to make sure that you know which one is which. Okay, and as you can see, so the blue one is the actual sale. And if you look at the gray one is pretty close. It's actually following it very closely, right? This is the trend and seasonal and trend forecast, whereas the orange one stays this, actually, since we are killing the trend effect, we're ignoring the trend effect, it just fluctuates around a constant mean, but with the consideration of the seasonal effect, which is not great, especially as you as you proceed, as you go to the next year. If the trend is still there, it's gonna really underestimate your sale for the next year and the years ahead. So this is really how we can solve these type of question. If you also want to, this is again is not a part of this question, but if you want to make a trend, so we did seasonal and we did seasonal plus trend. If you want to also compare a trend forecast, you can do that. And let's see if trend also, what trend does. So if I just take this over here and add the equation on my trend line here, just to get the equation. So for trend, I just need to get this number and use it for prediction, right? So y hat is equal to slope times period plus the y-intercept. So if I just take that, come here, so trend forecast is going to be equal slope times period is 1 for the first one, plus the y-intercept. And that's it. You can just drag it down all the way to the end of the fourth year. And the last four numbers are my forecast for the next year if I use trend. And again, let me just show you the formula that I use for trend forecast. And if you want to add it here, add the trend, select data, add, series name is trend, series values are all the way to 14. Okay. Now you can see what is happening to my graph here. So I added the trend, and as you can see, it now ignores the seasonality. Of course, the more complete model is when you have both seasonal and trend effect